let us get into our algebra for today. So guys, remember what we've been having a look at is basically algebra that now involves the multiplication or division of variables. So essentially what we've been looking at is including or incorporating our exponent laws into algebraic expressions. And this is essentially what you need to be able to do. Remember, I've said to you quite a few times that maths, as you keep going on into like higher grades, maths really becomes about being able to apply knowledge from different sections across sections. And this is one of the first sort of examples where we start to apply our knowledge from one section in another section. So we are going to recap exponents and algebra in our revision courses, but for now, hopefully we're all on the same page. Let's have a look at our first question here. So the first question is asking us to simplify the following. Now, firstly, grade 8, obviously it's all well and good me giving you a question, but if you don't understand what the question means, you're not going to really get anywhere. So firstly, whenever you see the word simplify, you need to be thinking of a couple things. You need to be asking yourself, is there any distribution I need to do? Are there any fractions or any division that needs to occur? And once you've dealt with those two things, do you have any like terms that you can add or subtract? So this goes back to our lesson from last week, Wednesday, where I said to you that if we follow 3 easy steps, we are able to simplify any expression that we're given. So those 3 steps that I gave you, if you don't remember, are firstly to identify how many terms or what terms you're working with in your expression. Your second step is then to simplify these terms individually. We want to simplify each term before we move on further. And once you've simplified each term, this is now where we find our like terms and we start to add or subtract. Okay, so basically these 3 steps follow BODMAS. Identifying our terms just helps us first figure out what it is we need to do. Simplifying each term is then the brackets, division, multiplication, exponents of BODMAS. Don't quite know how to write exponents, but basically it's the first part of BODMAS. And your like terms are the last 2, the addition and subtraction that BODMAS tells us to do in terms of the correct order of our work. So if we follow these 3 steps in our first example, we first want to identify our terms. Now remember, to identify our terms, we look out for plus and minus signs that are not in a bracket or a fraction. So this would be this minus sign and this plus sign. This minus sign is inside a bracket, so I don't need to consider it. And what this tells me is that I've got 3 terms in my expression. 5x is my first term. The minus times 2x minus 7 is my second term. And my third term is the positive 8x. So remember, those plus and minus signs separates my terms. And now I know exactly what I'm working with. Once I have identified my terms, I want to simplify each of my terms. Now, sometimes you don't necessarily simplify every single term that you're working with. So for my first term, 5x is 5x. I can't do anything with that. That's as simple as it gets. However, when we get to our second term, what we see is that we've got brackets, and that implies to me that there's some sort of multiplication going on. Now, what we need to remember, grade 8, is the fact that whenever we've got a bracket without a coefficient, so whenever there's a bracket with no number in front of it, we do actually have an invisible 1. And so what this means is I need to take this coefficient of -1 and I need to distribute, or I need to multiply it to the terms in my bracket. So in simplifying this, I get -1 times 2x, which is minus 2x. A -1 times a -7 is a positive 7. So I have distributed and simplified my terms, leaving me now only with plus and minus. This is now where I go and identify my like terms for myself. So remember, you can grab a highlighter, a colored pen, whatever you want. Like terms are terms that have the same variable and exponent. So I see I've got a term with an x in it, 5x. I've got a term with a -2x. And I have a positive 8x term. So all of those are like terms because they all have a single x in them. This plus 7 is a term all by itself. It is a constant. It is not the same as the x terms. Once I've got my like terms, I can now start adding and subtracting. Now remember, if you prefer to group all of your like terms together before you start adding and subtracting them, that is absolutely fine. Just remember to keep the signs correct. And so what that means is we have got 5x minus 2x, which is 3x. 3x plus 8x is 11x plus our constant of 7. There are no more like terms left, which means I can't simplify my expression any further. And so this is where I stop. So I followed my 3 steps: identify my term, simplify my term, and add and subtract my like terms in order to simplify this expression. All right, so I want you to take screenshots at this point. If anyone has any questions, now is the time to ask. Otherwise, we're going to see the next one, and maybe I'll let you have a go by yourselves. So again, screenshots. If you have a question, you can raise your hand at this point. No questions, grade 8s. Remember, guys, you are also more than welcome to use the chat for your questions. I lost my train of thought. You're welcome to use the chat for your questions. If you put your question in the chat, Yolanda or myself will answer it either as a message, or once I finish the example, I will address whatever your question is. Okay, cool. Right, okay. Guys, let's try and raise our hand as well when I ask you to, because now when I'm trying to move on, it becomes a little bit complicated. So when I say raise your hand, please do it. Semtanda? There should be a pop-up to unmute yourself. There we go.
Hi, ma'am.
Hi.
Ma'am, my question is, what I did over here is that I put brackets before the 5 and after the 8.
So you put what?
7. Is that okay? A bracket. Where you write in black, ma'am.
Yeah, okay.
I put a bracket in front of the 5. Excuse me.
So like that?
Yes, ma'am. Is that okay?
Yeah, that's fine. As long as you get the same answer, it's not really changing anything. So that's absolutely fine. If you would like to put your like terms in a bracket, that's fine.
Okay, thank you, ma'am.
Sure. Just quickly on the chat, Lisa Kanya, why do we get a 1? Remember, in front of any variable or bracket, there is always that invisible coefficient of 1 there. We don't always write it in, but it is there. Atlahang, I'm assuming that was your question because you've lowered your hand. What was going to happen if the 2x was negative? Well, then we just have to be careful of our signs when we multiply. So if 2x was negative, we would be multiplying a negative 1 by a negative 2x. So that would create a positive 2x. So whenever we've got negatives, it just means that we need to be very careful when we are multiplying or dividing. Okay. Right, guys. Cool. Atlahang, thank you. I'm glad you are all sorted. Guys, Atlahang has also showed one of our class rules here. When you hear your question has been asked, don't ask it again. Okay, so Atlahang was listening, realized that the question was answered, so we're all sorted. Okay, so let's have a look at question B. I'm going to help you a little bit, but then I'm going to let you do this by yourself. If we have a look at question B, again, we would follow those 3 steps, but hopefully what we're starting to see here, though, is that because we've got one fraction, it's actually just one term. I've got no separate terms in my expression here. I'm working with one term and that's it. So yes, I've identified my terms, but now if I want to simplify my term, I'm just working with this fraction. Now, the first thing that we always want to check when we've been given a fraction is, can you simplify your numerator or denominator? So we want to check, are there like terms? And we can see that in our numerator, we've got multiple terms, whereas in our denominator, we only have one term. So we want to check, are there like terms in our numerator? Now, this is again where we need to know what our we need to know what like terms are. Like terms need to have the same variable and the same exponent. So all of these terms here have a y in them, but all of them have different exponents. The last term has an exponent of 1, the 4y has an exponent of 2, and the 8y has an exponent of 3. Because all of those exponents are different, these are not like terms. So now we've got a bit of a, let's not say a problem, but now we have to think about, okay, well, if I've got no like terms, it means I can't add any of them. If I can't add any of them, what does that mean I can do in order to simplify? Now, remember, this is a situation where we can take our bracket, and because we've got no like terms and we can't do anything with it as it is, we can distribute or we can separate our fraction. So this is a type of distribution that we work with when we have fractions. So what we can do is we can separate our fraction into 3 different fractions. And this is absolutely fine to do because remember, they're all over this common denominator, which means they all as separate fractions had exactly the same denominator. And once we've done that, we can now see that we have got 3 terms, and we can now try and simplify each of these terms. So we can follow those 3 steps that I listed in the last question. So that's where I'm going to leave you guys. I want you to try this example. I don't know why there's so many B's and C's there on the side, but we're just going to ignore it. I want you to try this question, guys. I want you to have a look and see, can you go and simplify? Can you go and simplify this expression for me? I don't really understand why I've got weird B's and C's here, so let's just get rid of them. Right, so you're giving this a try. You're putting answers in the chat when you have them. Simplify this expression for me. Remember, once you've simplified these terms, always double check to see if you still have like terms that you can add or subtract. So we're going to wait for answers on the chat. I'm going to give you a few minutes, give it a try.
And guys, remember, we don't laugh at each other in this class, okay? We are all helping each other, right? And we are welcoming and we are heart-warmed people. So we don't laugh at any other questions that are being asked, okay? Let's focus now. Y'all are doing well.
Guys, just remember, if you're rude, then we just take you out the class. It's quite simple. Remember, deal with each fraction individually. And guys, remember to apply all of the rules that you've learned. So some of you might like SNV, signs, numbers, variables, for multiplication and division. That's fine, use it. Remember your exponent rules. What happens when you divide with exponents? So just bear all of this in mind as you start to simplify this. Min and Claire, we can see that you're struggling with audio. I don't know if you can hear me, but you need to look at the chat for what you need to do there. Okay, how do you type an exponent? So I know some of you can actually type an exponent and it looks like an exponent. However, Zanera, what we need to do to type an exponent is we use the little like hat looking symbol. So if you push Shift-6, you get a hat. So if you wanted to type, let's say, for example, 2x squared, you would type 2x, Shift-6 with the hat, and then you type the exponent 2. This situation over there tells you that you're working with an exponent of 2. So guys, that's how we type an exponent on like a laptop or a phone. Keep those answers coming, guys. The only hint I'll give you is that you shouldn't have any fractions in your answer. So once you found an answer, you shouldn't have any fractions going on there. Alrighty, grade 8. Let us have a look. So if anyone wants to raise their hand to try and explain how they did this, now's the time. I'll give you 2 seconds to decide if you'd like to, otherwise I will explain it. Nice, Nelson. Okay, Nelson, do you want to explain for us?
Ma'am. So, ma'am, so I first said 8y over 3 divided by 2y.
Mm-hmm.
So I said 8 divided by 2, which gave me 4.
Good.
And then I added the y. And there's always an invisible 1 by the top of the y. So I
Good.
added the powers together, which gave me 4.
Okay, so just be careful when we are now dividing. So if I'm saying y cubed divided by y to the power 1, division tells me to subtract the exponents. So I'm going to have y squared. Do you remember that law?
Sure, ma'am.
Okay, do you want to carry on?
Yes, ma'am.
Okay.
Then I continued with the second term.
Mm-hmm.
I said 4y to the power of 2 divided by 2y to the power of 1, which gave me 2. And then I minus the powers. 2 minus
Good.
1, which gave me 1.
Good.
And I continued with the third term. 2y to the power of 1 divided by 2y.
Oh, yeah. Thank you. Yeah.
Okay, to the power of 1. I said 2 divided by 2, which gave me 1.
Mm-hmm.
1, the power 1 minus the power 1, which canceled each other. So that means the y got cancelled and there's no more y.
Excellent. So is this our final answer over here, Nelson?
No, ma'am. Then I said 4y to the power of 2 plus 2y to the power of 1, which gave me 6y to the power of 3.
Okay, just be careful. Why can't we add these? Are these like terms?
No.
No, good, well done. So guys, just remember, even though they both have a y in them, those exponents are different. So they are not like terms, which means we cannot add them. And so what Nelson has done here is our final answer because there's no like terms there. I can't go any further. And so there where Nelson has said to us 4y squared plus 2y minus 1, that is it. Very nicely done, Nelson. Very nicely explained as well.
Thank you, ma'am.
Right, now guys, just quickly, you do not have to write that power of 1. So over here by the 2y, you don't have to write that exponent. You can if you want to, but it's not necessary. The next thing is there was a question of how did we get minus 1? So if we just go back up here, oops, we've got a negative 2y divided by a positive 2y. So firstly, whenever we divide something by itself, whether it's 3 divided by 3, y divided by y, anything divided by itself is always equal to 1. So the 2's cancel, the y's cancel. I have 1 left. But because it was a negative divided by a positive, we know a negative divided by a positive is a negative. So that's why I end up with a negative 1 as my simplified third term. Okay, so Lisa, I hope that makes sense. But we end up with a negative 1 because we were dividing a negative by a positive. Well done, grade 8. Very, very nicely done. Alrighty, let's try one more and then we'll think about a brain break. Again, apparently I'm now at A, but we all know that we are at C here. Don't know what's happening with my numbering, but we'll just pretend it's all fine. Right, so question C, again, I'll help you a little bit. I'm just going to stop here if anyone needs to still take a screenshot. at B. I'll help you a little bit for C, but you're going to try it by yourselves. I see there's once again. I'll just give you 2 more seconds for screenshots, and then we're moving on to question C. Alrighty, so if we have a look at question C, again, we can go and identify our terms, etc., etc. But hopefully what we see here is that the only term that we have, the only sign that we have in terms of positive or negative is inside the bracket. I've said to you, we don't consider this. So this is actually just one whole term. Now, if we want to simplify this term, hopefully what we see is that because we've got these brackets here, this is implying to me multiplication. So what we want to do is we want to distribute, or we want to multiply this 2x squared y to the 2 terms inside my bracket. So to simplify, I need to distribute here. So again, I'm going to give you 2 or 3 minutes. I want you to try, pop your answers in the chat, and then we'll have a look at them in a section. Guys, you need to be taking screenshots when I give you time to. I can't be scrolling back to the first questions. So I'll go back when I'm done with this question for you to take a screenshot, but please let's all focus when I say screenshot time. I always give you time to screenshot. There's no excuses. So those of you needing a screenshot of the first 2, I'll go back just now when I'm done with this question. So guys, what I'm going to say here for this one is remember your exponent laws. We've just done an example where we dealt with the division law. Remember your multiplication law for exponents tells you that if you are multiplying the same basis, say for example, x squared times x cubed, the law tells us that we add our exponents. So bear this in mind when you are now distributing your 2x squared y into your bracket. Remember your SNV as well, signs, numbers, variables. If you need to just break down your multiplication for yourself, which is absolutely fine. Rather break it down and get it right than rush and get it wrong. If none of you or some of you don't know what SNV is, it just stands for signs, numbers, variables. So when you're multiplying and dividing, first deal with the signs. A positive times a negative is a negative. Then deal with your numbers. 2 times 3 is 6. Then deal with your variables. X squared times x cubed is x to the power 5. So break it down for yourself so you can correctly get the product. Vashali, you could start with the bracket, but there's no like terms in the bracket. So we can't actually do anything inside that bracket. So we actually have to start with the distribution. Right, for those of you that said you were struggling with network, my hint to you here was you need to distribute. So you need to distribute the 2x squared y into your bracket. Those of you who are struggling to see the screen, again, scroll up in the chat to Yolanda's message, but because I know not all of you do that, there's a hint as well. There's a helpful, hopefully, method. And guys, again, telling me you don't understand, you don't want to do it. Firstly, if you don't want to do it, rather leave the lesson. And secondly, if you don't understand, I'm giving you hints. Try. I'm telling you to distribute. So try distribute. We are going to go through it so you can correct yourself, but try. Rather get it wrong now where not it doesn't matter, but where you've got the space to correct yourself and you've got the space to learn, then just not try and get to an assessment and then panic. Swallow, can we use BODMAS? Essentially, you are using BODMAS here. So BODMAS in terms of you have to do the multiplication, so the distribution first, before you start doing anything else. So we are using BODMAS here. We have to distribute or we have to multiply first. And guys, if you're not understanding this, you need to go back and rewatch the videos. We have done lessons on this. So it just means that either you didn't listen in those lessons, you weren't there for those lessons, there was some sort of connection issue in those lessons, but you need to go back and watch those. So Novisa, let me try that whole sentence again. The rules of like terms do apply, yes. So once you've distributed, you do want to check if you've got like terms. We always do that after we have simplified our terms. All right, guys, there's quite a few people who are feeling a bit confused, so I'm going to go through this one myself. So firstly, what I'm going to do is I'm going to draw a little multiplication block for myself. Remember, if you need to do working out separately, that's fine. Rather do that. So as we can see, our first distribution that we need to do is the 2x squared y times the 3x. So if we follow SNV, a positive times a positive is a positive. Numbers, 2 times 3, so the coefficients, 2 times 3 is 6. Now we deal with the variables. So we always need to multiply the same variable. So x squared times x. The rule tells me that when I'm multiplying the same bases, I add the exponents. So x squared times x, which we know has that power of 1, as Nelson explained earlier. We add those exponents and we get x cubed. So we've got 6x cubed. We also have this y here, but there's no other y to multiply it with, so it just stays y. So from my first product, I get 6x cubed y. Now I need to do my second product. So my second product is the 2x squared y multiplied by negative 4y squared. So again, SNV. Positive times a negative, that's my signs. Positive times a negative is a negative. Numbers, 2 times 4 is 8. And now we deal with the variables. Again, remember, you need to deal with the same variables when multiplying. So here I've got an x squared, but I've got no x squared in my second factor. So it's just going to stay x squared. Then I've got a y times a y squared. Again, apply your rule. Y times y squared. Again, remember that y has an exponent of 1. Our exponent rules tells us to add the exponents, giving me y cubed. So y times y squared is y cubed. So my second product is negative 8x squared y cubed. Now again, this is where we need to always double check for like terms, as I said to you. Like terms, I'm just going to write it out again for us, are terms that have the same variable and the same exponent. So they need to have the same variable or variables and we need to have the same exponents. So what this means is if we go back up to our expression, both of these terms have an x and a y in them. So they've got the same set of variables. That's the first one ticked. But now I need to check, do they have the same exponents? The x's have different exponents. So that automatically means they're not like terms. If we just want to double check ourselves, this y has an exponent of 1. This y has an exponent of 3. Different exponents. So that means they are not like terms. Because they are not like terms, I can't do anything else with this expression. I need to stop where I am. And so, oh, it's a bit of an aggressive pen thickness. Let's try that again. So I stop with what I have, 6x cubed y minus 8x squared y cubed. That is it. Okay, so questions in the chat. Okay, the only question is, how will we get in y to the power 3 when we're multiplying? Exponent rules. Guys, we've done this. Exponent rules tells us that when we multiply with the same bases, we add the exponent. So this is y to the power 1 plus 2. 1 plus 2 is 3. In essence, what it is doing is saying we've got 1y multiplied with 2 y's. In total, I'm multiplying 3 y's. If I've got 1 and 2, in total, I'm multiplying 3. That is what the exponent tells us. So that is where we get it. There's a question of, did we multiply the 2 by 3? I'm assuming that you mean over here. Yes, I did. Let's get a different color here. 2 times 3 gives me the 6. So that's why I've got a coefficient of 6 there. I'm not answering how did we multiply the 2 y's. I've just explained that. Exponent laws. Right. Sandiso, yes, you don't have to say y to the power 1. You can just say y. That's fine. Sometimes it's helpful to write the 1 there, just to remind us that we do have a 1 that we need to add. But honestly, if you're comfortable with exponents, there's no need to. Okay, so to November, if there are like terms, then we would need to add and subtract them. So if, for example, this had been, oh, hang on. So for example, this had been 6x squared y cubed minus 8x squared y cubed. So exponents are the same, variables are the same. Then we'll have to subtract them. Then we will get minus 2x squared y cubed. Remember, the exponents don't change when we add or subtract. But if there are like terms, we do have to do that extra step and go and add or subtract whatever our like terms are, because that will allow us to fully simplify. Right, take your screenshots, grade 8. Those of you who wanted screenshots of the earlier examples, I suggest you get ready, because I am going to go back there, but not for long, so be ready. So guys, again, this is you needing to be able to apply both exponent laws and algebraic knowledge. Okay, if you can't do that, you're going to struggle with algebra. Boutle, there are no like terms because when we multiplied, we didn't get like terms. That's how it happened in this question. Sometimes you do get like terms, sometimes you don't. In this case, my exponents for the x's are different and for the y, and because those exponents are different, they are not like terms. Right, question A and B, I'm just doing them both at the same time. There you go, screenshot. So those of you asking, do it now. You've got a whole 10 seconds. Guys, unfortunately, remember, brain breaks only happen if we get through the work that we need to get through. I am going to say, though, just get up, stretch, move in this 1 minute while we're waiting for people to take screenshots. But we're not going to do a full-on brain break. So you've got 1 minute to stretch, to move before we carry on. Andila, I'm very glad we're understanding. That's awesome. Right. So, Boutle, your question of why are there no like terms? What we're going to see in this next example is what happens when we do actually have like terms. So hopefully this will also help answer your question if you weren't really hearing or getting what I was saying. Hopefully this will help. But we're going to have a look at this example now in a minute or two after you've all had a bit of a stretch. And we'll see what happens when once we have distributed and we still have like terms, what do we do? Okay, so I'm not just sitting here in silence. I've told you that if you want to have a quick stretch, you must do that. So we're going to have a look at this example now. So get yourselves ready. Alrighty, let us have a look here at this question. I'm pretty sure we're on question D. Yeah. Okay, so if we have a look here, guys, first things first is we need to identify our terms. So exactly, Loazi, well done. Remember, we only consider plus and minus signs outside of the bracket. So this is separating my expression into two separate terms. Right, because I now know that I've got two terms here, I now need to check if I can simplify any of these terms. Now, the first term I can't do anything with. It's just 7x cubed, not being multiplied by anything, divided by anything, nothing. So it stays as it is. But in my second term, I see that I can distribute. So what I see here is I can take this minus 5x and I need to multiply to the x squared and the y. So if we do our multiplication block again, just to help us, minus 5x times x squared. So we've got a negative times a positive, which is a negative. Remember, there is that invisible 1 in front of the x squared. We don't write it, but it is there. So 5 times 1 is 5. And now when we multiply the x's, x times x squared, I've got 1x being multiplied with 2 x's. So in total, there are 3. So this is x cubed. So minus 5x cubed. My second multiplication is minus 5x times minus y. A negative times a negative is a positive. You can put the positive there if you want. You don't have to. Just remember it is positive. Again, there is a 1 in front of that y. We just don't write it. So 5 times 1 is 5. And remember, guys, if your variables are different, you can't apply the exponent law. So x times y is just xy. That's it. So now we've got plus 5xy. So this is now back to the question about like terms. What we see here is that 7x cubed and minus 5x cubed are like terms. They both have an x cubed in there, making them like terms. This 5xy, it has a y, so it is not a like term to the rest because it has a different set of variables. So I can now add my like terms. So 7x cubed minus 5x cubed is 2x cubed plus that 5xy. So when you do distribute and you end up with like terms, you need to deal with it. All right, so in this case, once I distributed, I did end up with like terms, and so I needed to add and subtract them. Take your screenshots, guys. If at any point, oh no, hang on, let me restand. I'm gonna start all my words again. If anyone has any questions, now is the time to raise your hand. All right. Please, though, take your screenshots. So Nobise, essentially, the quizzes that we do every week are practice. So the quiz last week, I would definitely say go back and redo if you haven't done it, or redo it. And then the quiz on tomorrow. The quiz tomorrow will also deal with this algebra stuff. So it'll be more practice of it. And we're going to do more practice on Wednesday of these concepts as well. So there are quizzes available if you want to try. But yeah, in terms of what we provide, that's it. Salvated, why don't we add the cube exponents? Okay, this is a very good point. So the question is, why don't we add the cube exponent? So that is essentially asking, where we've got these like terms, why aren't we adding the cubes? Remember, when we add or subtract like terms, we never change the exponent. The exponents. Right, and the reason is you're adding apples and apples. We can't all of a sudden have apples squared or apples cubed. They need to stay apples. So x cubed plus x cubed must stay x cubed. I'm working with x cubes. Okay, but very good point. Well done. If you need to take a screenshot of that, I'll just leave that up for another 2 seconds.